Okay, so today what we are going to do is to uh, talk on pig and do some practicals on it. So we need to cover four things. So as of now we have covered scoop and hive. So basically, suppose if you are preparing for Hortonworks developer certifications, four components are needed. One is scoop, one is hive that we already have covered. Then we will cover pig and flume. You know, so basically, these four components, you will get around 7 questions out of these four components, and out of those seven questions, you need to at least correct 5. Okay, so mostly it would be three hive questions, 2 pig questions, 1 scoop, and 1 flume. Okay, so scoop is like import, and it would be quite easy. Okay, if you just know the parameters, how to pass them in scoop import. Even flume is also a very easy question. And hive, you will have one like kind of table join and then do some kind of sorting and other things, right? In pig also, we need to perform few things. So what is pig basically? So let's start talking on pig. So pig is again a data flow language. Okay, so it had been there for prior to Hadoop. Okay, so it's not like the part of actually you can say core component of Hadoop. Okay, so because pig was developed by Yahoo, and it was like it had been developed from the perspective of doing the data analytics, or basically it's a kind of data flows. Okay, so there could be multiple stages where you are trying to make the changes in the data and then get the final transformation of your data if you want. Okay, so you will start with the original data set, then transform it little bit and to the next level. Then in the next level you will transform it further little bit to get to the next level, and then finally you will get the data. So the good thing about pig is that basically it's like kind of a procedural language you will follow from step by step. Okay, it's not like hive. So sometimes hive gets completed. Suppose if you are having like multiple table joins, okay, so the query itself may get around 100 or 200 or 300 lines of query. So it is somehow sometimes not readable properly. And the bad thing about hive that I don't like is that the debugging is very hard in terms of why, because if you will get the complete query executed at once. Okay, that's what we are saying. Suppose whatever you have whatever you have written in hive, basically all that will be compiled once and fired once, okay, at a single time, and then it's very difficult for you. So like if you do some Java programming or Scala programming, Python programming, or any procedural language programming, we do have a control, like step by step we can go ahead and try to understand where the bug could be. But in the large SQL, suppose if you are writing large SQL, it is very sometimes difficult. Okay, so for the newcomer who is actually looking to that query for the first time, it may be he may find it difficult to understand it in the first shot. He may try to run it multiple times and try to understand the things. Okay, so in with that particular perspective, pig is quite easy. Okay, because it is like kind of a procedural step by step of things that we need to follow, and we will get the similar result as what we can do hive. In pig also there would be possibility of doing joins and all. Okay, so let's start. So pig is basically data flow language. It was designed by Yahoo. Okay, it had been there prior to Hadoop, so they have just like added a plugin into Hadoop also, so that we can leverage the easiness of pig in order to do the data transformation. Okay, now the thing is, I mean, really the pig is getting used in production or not. So sometimes it may be. There are companies who are actually working on pig. Okay, there are companies who may not work. Okay, and they will prefer hive. Now the definite question that you may get in an interview is basically, what is the difference between pig and hive? Okay, what is with pig you can do easily that cannot be done in hive, or what is in hive that can be done easily that cannot be done in pig? Okay, there are like kind of comparison questions between pig and hive. Okay, definitely. So the answer to that question is actually there is nothing impossible in both of these tools. Okay, hive and pig, you can compare them equally. Okay, what hive will give you, like since you know that the data would be structured when you deal with hive. Okay, so you will be sure that while doing the read on, so schema on read, right? So hive provides you the schema on read, not the schema on write basically. So when you do schema on read basically, and if the data matches the schema of your table, you can easily do the analytics very faster, just writing very small queries, okay, not large queries, okay. Pig, what does it do is basically it provides you the way to make the unstructured data more structured. Okay, suppose if you got a flat file, okay, there is no proper length of each line. Okay, so let's say the first line is of 100 character, second line is of 90 character, third line is maybe 105 character. Okay, so we can just treat this data to be unstructured, because if we put that first record is very first record is lengthy, then second record is less lengthy, and then third record may be more lengthy. So we do not have any structure in that kind of data. Then what we'll do? Okay, so so on the unstructured data part, basically you can start with pig and do some kind of little transformation to the data and make it more structured. Okay, try to fix the length of the flat file for each line. Try to get that what are the maximum length of line you are having in that particular file. Try to identify if that particular line is having all the necessary information you want. So maybe it may happen that some of the lines may missing some necessary information or some extra information, whatever, maybe it is optional information. Okay, so then you can just try to think on the structure and try to convert whole lines in that similar kind of a structure. And then once you structurized your data that was earlier unstructured, then you can easily create a Hive schema on the top of it. Okay, so pig will help you to make some unstructured data into a structured one. And then once you get some structured, uniform structure of your data, basically with that uniform structure you can easily create Hive schema on the top of the data, and then you can go to Hive if you like SQL. Else, if you don't want to do the SQL and try to work with the data flow language, if you find it's very easy, then definitely you can also go ahead with it. Okay, so pig and Hive both equally give you the ability to do the data transformation, data analytics on the top of your HDFS data. Again, this pig also works on the top of HDFS data. But then, since pig had already been invented, you can say, prior to Hadoop, it also works on your local file system. Okay, so you really don't want always the HDFS file system to be the source of your pig data flow transformations. Okay, so it can also work with your local file system data if you have some data in your local file system. Okay, so it also may be possible that you will get some large file on your local file system, let's say 100 GB. You will just analyze it with pig, okay, and then do some transformation, and then give me one second. Okay, so now we need to understand basically so how basically pig works. Okay, so pig gives you the ability of working with local file system data as well as your HDFS data. It will also work on both the execution engine. First, that is one is MR, that is MapReduce execution engine, and second one is Tej. Okay, so we have seen that Hive mostly optimizes the query for Tej engine, or Tej is basically, you can say, the optimization engine or query engine for Hive. So same thing can be used for pig also. Okay, so pig can work with Tej, pig can work with MR, MapReduce. Pig can work with local file system, pig can work with HDFS file system. Okay, so it gives a lot of flexibility in terms of from where you can choose the data source, you can choose the optimization engine for it. So you can first bring the data into your local file system and try to do some local transformation to it if you can make it right there, again, instead of putting it into HDFS and working with there. If the data set is smaller, like around 50 GB, 60 GB kind of thing. Okay. Sometimes you may get sometimes you may get the daily insertion of data and on the daily basis. It may be around 50 to 100 GB. So you can get it into the local file, do the some transformation there, and then load it into HDFS and then create a table on the top of it. Okay, or if you have some like 500 GB, 400 GB, like that's some huge amount of data you started creating, you can load them into HDFS. Load that into HDFS and then start doing some pig transformation. Okay, so the beauty of pig is that every stage you can see how the transformation is happening basically. So that is the beautiful thing. I mean, when you start writing transformation, you think of certain algorithm and try to apply it on your data, and then on the next stage, on the very next stage, you can just visualize it, whether you are whatever you are thinking on your transforming your data, is it really going fine or not? Okay, so you can just watch some of the lines whether they have transformed perfectly. Okay, if you see that okay, the result is perfect, you can go further ahead, and one more step you can move ahead and try to do the further transformation, and then again visualize your result whether you are going in the right direction or not. Okay, so that is the very good thing. Okay, so it will, like, from top to bottom you will be very sure that okay, you are going in very right transformation ways, and you finally get what you want. Okay, the relation will not be executed until again there is a term called lazy execution. Okay, it is very important term related to the big data world. Lazy execution, most of the frameworks now, they like Spark framework has come, it also has used this property called lazy execution. It means that when you write the transformation, it will not execute right then. Okay, just like when you fire the SQL, it will execute all the things from the top to bottom, right? In Pig it is not so. You will write the transformation, okay, create a relation, create a transformation, and you can create the series of transformation, but they will not be executed right then when you write it, or when you write them. Okay, they will be executed only when there are few keywords that you can call on the final transformation. Okay, so I will explain this now. So the lazy execution will happen only when you use dump or restore. So these are two keywords, okay, that you will take on the final transformation will force the completed DAG. Okay, so let's say you have done the transformation 1, okay, then you have done the transformation 2 on the output of your transformation 1, then you have written transformation 3 on the output of your transformation 2, okay, and then you have written transformation 4 that is on the output of your transformation 3. So it is series of transformation one after the other. Okay, and then you, on the final transformation, if you are running or executing this dump or store keyword basically, then the complete from the transformation 1 to the last transformation, the whole thing will be executed in sequence. Okay, so that is what is called lazy execution. Okay, so when you're writing a transformation, right then it won't execute. It will be executed on the final transformation when you put some dump and store. Okay, so this is just for now. We will see that practically. Okay, now there are some input and output keywords. Okay, so input and output keywords will help you to get, so this you can say these are the output keywords. Okay, either you can dump it on the console. The very little difference written this is that dump will just show the result on your screen. Store will store the result on some data location or like HDFS location. Okay, you can also store the result on your local file system. You can also load the data from your local file system, and then after doing the transformation you can put it into HDFS, or other way around. You can start with HDFS data, and if you want to finally put your data into some local file system, you can also do that. Okay, but then you may need to start the Pig in that kind of mode where you will work with either local file system or HDFS file system and so on. Okay, while starting the Pig utility, basically you can provide all that information that you want to go ahead with Tej execution engine, or you want to go ahead with MapReduce execution engine, or you want to go ahead with local file system or HDFS file system. Okay, so load, store and dump are the keywords that will use as the input. And so load is basically the input keyword. This is what you need to use to load the data into some of the Pig relation. Okay, so when I say Pig relation, it is a kind of a variable that will hold the data for a time being in order to do the transformation of that data. Okay, so this is very small command of again the Pig, that how we can create a relation. Okay, so I will try to explain it here. It's very simple to understand. Okay, so basically just try to look into this particular school. Okay, so this is what is said to be variable or relation in terms of Pig world. Okay, so in Pig world, this particular variable where we are actually, so when it is just like saying school is a variable, we are loading something into it. Okay, this variable is said to be relation in Pig. Now this load is the input keyword. Okay, it will tell you that whatever is following after load will be the location from where you want to load the data into a school relation. Okay, so if you see this HDFS and this is our path, and we have one school directory, and this particular data will be loaded into the school relation, or you can say it is actually pointing to the location where it is. Either way it is right. Okay, it is not actually do that. So basically it is just creating a relation. Okay, and when you write this, okay, you can also provide that what would be the delimiter in your data. Okay, so that the school particular, this is school directory, it is having certain files. Okay, that files will have actual data in HDFS, and the data may be delimited. Okay, delimited means there would be a delimiter in the data. It could be comma separated, it could be tab separated, it could be pipe separated, it could be column separated, semicolon separated, or any other special character separated. Okay, it could be anything. Whatever separator you are having in your data, you can just specify that using pig storage. Okay, so that this is a class. When you say P is in capital, basically this is class that will help you to parse your data using whatever separator you are providing over here, right? So here we are providing that a comma. A comma is a separator that I am expecting, or we are expecting this school data to have, or we can just first look the data, check what is the separator there in the school directory, and then use that one so that you can easily parse it out. Okay, then you can also associate a schema with it. Okay, so pig is not you can say it's not mandatory to have the schema always. It is optional, but if you have, okay, if you want to create a schema, if you want to associate any schema with the relation, you can also do that. So it is like most similarly to Hive now. Okay, so in Hive also we use the schema. In Pig also we can provide this schema, but it is optional. Okay, if you really want, if you can associate schema, it is always good, because then you will just pick up the columns or pick up the information as their field names or their column names. Okay, if you don't specify this, even there is a possibility of to name the columns with their positional values. Okay, so let's say there are 5 columns in a data. Okay, so the first column we will say it to be $0. The second column would be $1. The third column would be $2, $3, $4, like that. Okay, so even if you do not have a specific schema, just like this named schema, you also can work with that unnamed schema where the columns can be identified with their positional values in the data set. Okay, so as I said, if you are having 5 columns, comma separated records you are having, and if that comma separated record is having 5 columns, the column would be identified as a $0, and the 5th column would be identified as a $4. You will get a question in your Hortonworks certification exam where they will give you around 20 columns data and try to ask you to, will ask you to choose let's say 5th column, 17th column, 11th column, and 19th column, and then create a data set out of it, and then do some further transformation it. So at that time it would be very difficult to count. Okay, so what you can just generally do is count the number of columns in your data set, and if you are trying to pick up the 17th number of column, just do $16, because we know that all the columns number will be shifted -1. Okay, because $1, the first column would be $0, the 17th column would be $16. Okay, so you just need to remember this fact, that how you can identify the columns with their positional values if the schema is unnamed. Okay, there is no proper named schema is associated with the relation, then definitely you will go the positional values. You can go with the positional values, and positional values is the actual column position -1 is your positional value. So we will see that. Now this is how a school relation will look like. Now once you create this school relation by defining this, okay, and you need to end it with semicolon over here, so it will create a relation, but does it execute? No, it will not execute until unless you won't do any dump or store, this one is store or dump on this school relation. Okay, so if you do store and dump on this school relation, then definitely it will, this whole DAG is, what is the full form of DAG? Directed acyclic graph. So this is a term used for just keeping the connections between various relations in just memory. Okay, so when you start defining the relations, then you are expecting some transformation to be done on that relation, you will do the transformation, it will create the next relation, then next relation, then next relation. So it will actually, the DAG will be kept in memory. It will just, whenever you fire, store and dump on the final relation, the whole DAG from top to bottom will be executed. Okay, that is what is called DAG, directed acyclic graph. This is again one famous term, and you will find it in Spark. Okay, this lazy execution and DAG, these are two terms that you will find in Spark also. Spark is also working on the similar principles of doing lazy execution of the variables and creating the DAG, so that whenever you are trying to really execute on the final variable, all the previous variable will be getting executed sequentially from the top to bottom. Okay, this is a very good way, because it will actually save, because when you want to execute, then only it will execute. Okay, that is a very good thing. Otherwise, on every step, if you are working on terabytes of data sets, or at least thousands of GBs of data sets, then what will happen is basically every transformation will take some time, because as soon as you define it, and it will start executing. Okay, because, and even then, that is not your final output, that what you are expecting, because your final output will come after some sequence of transformation. Okay, then why to execute since beginning? And that is very beautiful thing in Pig, that it will be executed only when you want it. Okay, not as when you define it. That is what is called lazy execution. So let's move forward from this. Okay, then store will store the things in HDFS, and dump will just show the results on your screen. That's it. Nothing much difference in that. Okay. Now there are things that we need to, just like it is like within the Pig world, basically we will say row to be a tuple and the collection of rows to be a bag. Okay. So a relation set to be a tuple. Okay. Or you can say a particular record, a particular row out of your data set is set to be a tuple. Tuple, you can just pronounce it like that. So tuple is row, bag is the collection of tuples or collection of rows, you can say. So and then we do have some kind of parentheses and curly braces that will help us to understand whether it is we are actually pointing to a bag or we are pointing to a tuple. The other good thing is that, or you can say complex thing, or you can say some fact, that tuple can contain bag and then bag can contain tuple. So it is like kind of one within. Okay, you can have a tuple, and one column may have the bag. That bag is again full of tuples within. Okay, so bag can contain tuple also can contain bag, and then further bag will also contain tuple. Okay, so we will see this how it looks like when we do some practicals around it. Okay, now then we do have certain keywords. Okay, all these are keywords that we can just can take on the top of your Pig relations. Okay, again Pig will also give you the facility of loading the data and schema directly from the Hive table. Okay, so there is a utility called hcatalog. Hcatalog can be used very in a variety of ways. So hcatalog is a separate kind of utility that will help you to bring the schema and the data from Hive table. Suppose if you want to do some Pig transformation, and you already know that the Hive table is created on the top of that HDFS directory, from where you need to bring the data and put some transformations on it. Okay, so you already know that since it is Hive table is defined on that particular HDFS directory, it means that the Hive table already has an schema, and you can directly use that schema in your Pig transformations. Okay, and again, so you can load the data from Hive table with its schema, do some transformation, and again send it back to the Hive. Okay, so again it is like kind of a Hive to Pig communication, and it can be made just by using the hcatalog facility in between. And ultimately, if you on the abstract level, if you see both a Hive and a Pig is actually pointing to the HDFS directory only, because they are actually trying to pick the data from HDFS one. Okay, so we will see that also, that how you can communicate with the Hive tables, Hive schema, get the data, get the schema information, try to do some transformation and send it back to the Hive again using the hcatalog facility. Okay, hcatalog will also, not only between Pig and Hive, it will provide the kind of bridge between doing the sharing of information. It will also use in multiple other ways, just like providing the web access to your WebHKit and all. to the Hive in Hive Metastore and Hive Server 2 or Hive data that where it is pointing to. Okay, so again, and then that H catalog will be used in your examination question. Okay, so that's why it is very important to understand it, and it is a very it is very important to understand the practical of H catalog, just doing the data sharing between Pig and Hive. Okay, so let's do that.